Hello and welcome. This is Kellyanne Fitzpatrick from RedMonk here with another What is How To. And today, as our guest, we have Sabby. Sabby, would you like to introduce yourself?
Sure. Yeah. Hi. My name is Sabby Anandan. I am product manager in the Spring team at VMware.
And our topic today, what is a cloud native data pipeline? Kind of a lot of thoughts popped into my head when I heard that. So for instance, data is not something that is new to any of us, but my sense is that today's applications are more data intensive, and also there's different kind of types of data that we're expecting applications to kind of process. And on the kind of cloud native side, again, that's a word that's not new to any of us who's been paying attention to tech in the past, however many years, but it's definitely a word that has come to kind of mean a lot of different things to people. It could be kind of ubiquitous. Some people think it's more of a buzzword. Some people think it means only containers. So I think to start off, let's just go with what is in your mind, a cloud native data pipeline?
Yeah, I think you covered it really well. I mean, there's a lot of interesting trends that we see in the industry, and there's a lot of hype around this cloud native as a general theme. It applies to a variety of different systems. But I like this definition from Cloud Native Computing Foundation. It's concise, and it goes by something like loosely coupled systems that are resilient, manageable, and observable. Imagine extending these types of patterns and principles to a more series of data-intensive applications, where each of those applications now are independently or responsible for a particular data processing step. Now, given these series of applications are now coming together as one concrete use case, now they're cohesively become a data pipeline, so to speak. Yeah, so that's cloud native data pipeline from the way how we think about it. But I mean, it's not just about building applications and deploying in cloud and then sort of leveraging these types of benefits. But there's equally also a set of challenges that come with orchestrating these types of data pipelines at large scale.
There are always challenges.
Yeah, totally, right? Yeah, so you described that really well at the beginning about that there's data-intensive applications and there's cloud-native systems, and what is a combination of both? But specifically, when you talk about data-intensive applications, there's a large data involved. So there's a lot of large volume data that you need to think about processing. Developers and architects who are designing these types of applications now and they need to worry about not just hundreds of messages per second, but about millions of messages per second. Just imagine a credit card fraud detection use case where you have hundreds of thousands of credit card transactions that's happening in real time. You need to think about processing all of that data in a more concrete way, in a more manageable way. And some of those data set could be structured and then come with a lot of schemas. So you have a lot of producers producing different types of data and with different schemas attached to it. But then the consumers connected to that payload. Now, if the producer changes the schema tomorrow, and all the consumers would be breaking. So the developers and architects need to think about how I'm going to build a resilient system so it can be sort of future-proof and be backward or forward compatible as and when the schema evolves.
And I think that's a really good point, because if you think about building one application, right?
Yeah.
And what things need to do and what needs to talk to what when you're talking about more than one and then many and then all the different things that those different applications are dealing with, that's when things start to get a little complicated.
Totally. Yeah, you got that right. Yeah, I mean it's also equally challenging when you're building more data-intensive applications. The ordering guarantees are super critical. For example, if you're interested in understanding a particular IoT device's performance or what it's doing in real time, you need to be in a position to process all that events produced by that device and bring them all in a more ordered way so that you can do some stateful analytics and so that you can understand the performance or do some interesting analytics use case on top of it. And likewise, if something breaks, and you should be in a position to go back in history and retry and replay and things like that. So I mean, obviously, if you're thinking about cloud scale deployment, elasticity is another interesting thing, and you should be in a position to react to upburst traffic so that you don't have an application in your data pipeline that's a hotspot, it's a bottleneck. It should resiliently scale up and down as and when there's an upstream traffic throughput changes as well. So this, you can go on and on, right? So I mean, there's so many different challenges that generally distributed systems are challenging, but then when you throw in a state on top of it, it's a lot more critical and a lot more design thinking that needs to happen by the developer and architect like persona in building these architectures. Spring in particular, I had several projects, from 2007, 2008, they form the building blocks for building applications that interact with data in general. What I'm going to do next is I'll switch focused and walk through a couple of foundation building blocks, and then I'll switch to showing all these various things in action with a concrete use case. So hopefully then the concepts would resonate better for the audience who are watching it. So to that, next up, what I'm going to do is I'm going to talk about a couple of building blocks that particularly tackle some of the data-heavy use cases. The first one, what you see in my screen here is Spring Cloud Task. It's one of the framework within the Spring Cloud umbrella. It helps you build more applications that are more short-lived, but are useful for data processing use cases. What I mean by short-lived is if you have an application that needs to do a data migration job, for example, and that application needs to do that data migration job. At the end of the data migration job, it needs to gracefully shut down and free up that container and resources like memory and compute in general, so that it's not chewing up resources unnecessarily. So that's the type of design or architecture pattern that you can leverage by using Spring Cloud Task and build that type of an application so that you can get that benefit from it. Plus, this framework also handles a lot of those data processing and data partitioning, auto-scaling, those challenges that we discussed in the previous slide. The framework brings in primitives as auto configuration components, so developers who are using Spring Cloud Task to build these types of applications and use cases can override those behaviors with good properties and then get to a desired behavior at runtime. So that's one of the building blocks. Now, the more hyped up space that we see in the industry now is event streaming, right? So we have a project within Spring Cloud, it's called with the name Spring Cloud Stream. Here, the folks are building, developers can use this framework to build event-driven applications. Now, this is interesting because now you can think of microservices that are connected to a message fabric like Kafka, RabbitMQ, and others. Each of those applications are largely stateless, but they could be stateful when you're using Kafka Streams like framework. But those applications individually are doing some interesting stuff. They are more bounded in context, so to speak, but they have clearly defined schemas and whatnot. But individually, those applications are performing those data processing steps. But at the end of the day, you're building a coherent data pipeline made of microservices. I'd want to segue into a more concrete example. Imagine a customer who's interested in whose main business is renting trucks. Now, these trucks are producing all kinds of events. So one of the use cases I'm going to highlight here is, if you are to build a use case, if this company, for example, Penske company who's wanting to understand how these trucks are performing in real time. In this chart, what you see is all these trucks that are in the road and they're all producing interesting events. Now, if they want to understand how these trucks are performing, and one of the performance criteria they have is to analyze the brake temperature. In this chart, you have in the x-axis is the time and the y-axis is the temperature. And imagine they want to they ingest all these real-time events coming out from all these trucks, specifically the various stats about the truck, including the temperature, internal temperature, external temperature, the mileage and speed and load and variety of different characteristics. Now they can take all these things into account and then build more sophisticated analytics solutions to understand how they are performing in real time. Now, to do exactly that, what I'm going to do is I'm going to switch focus and then show a few applications, how someone can build these applications with the frameworks that we ship, and how they can then use Spring Cloud Dataflow to deploy and then orchestrate data pipelines in Kubernetes.
And so what I'm hearing is it's demo time.
It is demo time. Yeah, let's do that. So I'm going to begin with how someone can get started with these building blocks, right? So many of you are familiar with Spring Initializer, the start.spring.io, and this is a place where you can bootstrap your Spring Boot microservices rapidly. So you get to choose a bunch of versions and to build that specific use case, that event streaming use case that I just described, you need to be able to build a Spring Cloud Stream app. So the idea is you just choose the stream dependency. In my case, I'm interested in building a Spring Cloud Stream apps that communicates with Kafka and Kafka Stream. So all I would then do is select those dependencies in particular, and then generate a Spring Boot application. So now that's scaffolding for that application that's readily available. So that's scaffolding in the sense that event streaming opinions and primitives are automatically brought in by this framework. Now it's ready for your business logic. So I'm not going to go full length and writing code from scratch, but I'm going to like already have these applications built. I'm going to like quickly, briefly run through them, right? So I have 3 applications. So the first one is it's going to like generate trucks. The trucks that I'm going to simulate as if the data is coming from a truck. And each of those truck data is going to a topic in Kafka. And downstream from that, there is a Kafka stream processor that's going to like receive all this real-time events from trucks. And it's going to do a group by and window by operation internally to compute the moving window average of each truck's break temperature, right? So that's the primary use case that we are trying to build. And downstream from that, the computed average then goes to a different topic in Kafka. And finally, a third application consumes that result and then it prints it. So this is literally the use case that we're going to like see it in action. I already have those 3 applications built, as I said. As I also pointed out earlier, so you have those dependencies that you picked up from Spring Initializer. And this is my producer app. It's nothing but a Spring Boot app. And just by having it annotated as bean and with the supplier as the function type, Spring Cloud Stream automatically recognizes this as a producer, and it also has a scheduled emitting of a result by every 1 second. So every 1 second, we are creating a random truck and then like chucking it along to a channel, and that channel is automatically bound to a Kafka topic. All that is taken care of by the framework, the Spring Cloud Stream framework. Now, this is the value proposition for developers who are interested in writing producer applications or event streaming producer or consumer applications. At the moment they build a boot application with Spring Cloud Stream, all they really need to worry about is like annotating with like specific method signature, and the framework automatically converts that to a producer or consumer. It automatically also creates channels and binds to the Kafka infrastructure, including connection credentials. So it's completely auto-configured for them, and so that they don't have to repeat the boilerplate steps again and again.
I mean, anytime the configuration is getting done for you, that's a good thing.
Yeah.
When it's done correctly, of course.
Yeah, indeed. Now, my processor application is a little bit more interesting. Here, it's also a boot app, but here, if you see this method signature that I have, it's a function type. It's a Java util function type, right? So the function Java util package takes one input, does something, and then it returns an output. So it's one input, process, and then output, right? So that's literally what's happening here. We are receiving a truck object as an input. And inside that business logic, all we are doing is for every 10-second window, we are calculating an average temperature for each truck data that this function handler receives. And then the final outcome is sent out as the output as average break temperature accumulator object to a different topic. Now, anybody who's connected to that final topic will be able to see the results of what's happening for each truck. What's the current average temperature, or current average temperature for at least the last 10 seconds from an aggregate point of view, right? So that's the second application. Finally, the last application, which is nothing but a Spring Boot application, once again, but now it is of consumer type. And again, Java util consumer is nothing but receives some input, and you can do something with that input. In my case, I'm just like printing out. Now that we have seen these applications, how do we deploy them? So that's an interesting question, right? So this is where Spring Cloud Dataflow comes into play. I already have Spring Cloud Dataflow up and running in my local Minikube cluster. We provide tools and scripts for you to like provision Dataflow onto your Kubernetes of your choice. I just chose a humble Minikube cluster running in my local laptop. I have Dataflow, which is nothing but a Spring Boot app. It's running and it's port forwarded to a specific port. So this is a Dataflow UI. We also have other client experiences. We have a CLI tool that we ship. We also ship a set of APIs. So we have developer audience and architect personas who build CI/CD, more programmatic way of building these types of data pipelines. That's all possible too. But for this demonstration, I'm going to stick with just the UI. So the first landing page that you see here is applications. So this collection that you see is we have close to about 70 applications that we have as out-of-the-box applications. So for most common use cases, if you have data in Cassandra, you don't have to write an application for it. If you have an application, you just use it and then write to Cassandra or read from Cassandra. Same with Jumpfire. And if you have data in file systems, you have an app for that, or FTP, SFTP. So you all get the idea. So we have a utility set of applications that are ready to go. Now, this is also an interesting area because now we have customers who have like different business units who all build different types of event streaming applications and batch applications. Now they get to share these applications because these applications are reusable catalog of applications. So with that said, this is the first landing page in Dataflow. Now you get to like curate all the application, get visibility into what these applications do. There is Java docs for each of those applications, and each of those different teams within the business unit like work on these individual applications and production harden them with documentation. So other teams and other business units within the enterprise can get the visibility and discovery into all these applications and what they do, and they understand how to use them. Now, I have those three applications, as I said. Those things are already registered in my catalog. You can see that break temperature here, for example. So what I'm going to switch is we have this view called stream. A stream is a representation of a series of applications. So the idea is now those applications that you saw in the catalog, they all show up in the palette. Developers or any developer or analyst persona now, they can drag and drop and build those applications, build the data pipelines with it, right? But in my case, I'm interested in solving that break temperature analysis use case. So I'm going to like copy paste a DSL and that I already pre-created. So we have this DSL in Dataflow, which follows the Unix's pipes and filter syntax. Each application is separated by a pipe filter, which represents a channel. It's backed by a Kafka topic. So the data from truck performance goes to a topic, and downstream from that, break temperature picks it up. It does that moving window average that we just saw in the code. And then the computed average goes to a different topic, and downstream from that, this final consumer prints it. So I'm going to create the stream. I gave it the name truck performance, right? So now that the stream is created, Dataflow also provides you another option when deploying the stream. You get to select the platform where you want to deploy this to. And you also get to alter the behavior of each app's individual compute. I mean, whether it's memory, CPU, and whatnot, you can alter that behavior too. So I'm going to like plain deploy it, right? So what happens behind the scene is if I go back to my Kubernetes console, so you can see now Dataflow is like, deploying these three applications in my Kubernetes cluster. So it programmatically built out a deployment manifest for each one of those applications. And it automatically also like chucked in all the connection credentials for Kafka that's running in my cluster. So when these applications are bootstrapping, all three of them are independently starting, and they're all coming through, going back to that data pipeline definition that we discussed at the beginning. And each one of those applications are connected to a common message fabric like Kafka. And now, because they are all communicating with a common message fabric, and these three applications are specifically purpose-built for a common use case, they come together as a coherent data pipeline. So yeah, it looks like this is my producer has started and it's producing data, and this is my Kafka streams. It's doing that Kafka streams aggregate. You can see those stateful storage logs here printing out. And finally, my consumer, it's actually printing that JSON document for each truck. So here we've seen that JSON document. So the VIN number is there, and you're seeing the average, the moving average that's being printed out. Now, each of those applications are coming together. You can see those dots beneath each of those blocks. It basically says each one of those applications are one instance of each application is running. If they are scaled out, you will see a number of those boxes come and automatically adding below as well. So you also get details into like what's in this streaming data pipeline. So this is made of three applications, right? These are these three applications, and it shows the version of each of those applications. And it shows up the runtime stats. You can go to logs. This is basically the logs that we saw in Kubernetes cluster proper. It's the same logs here. So we sort of like stream it back to from a UI point of view. So you get a central control plane type of concept from the Dataflow UI for all these data intensive applications. And one last thing in the screen is you can see the same stream I deployed a few times. So you see there's this concept of history that we have. So this goes back to that more in the cloud native like systems. If you are to like think about cloud native deployment, one of the concepts that we discussed early on is the idea of managing these applications easily. Managing could be in the form of being able to flexibly update them as and when you need them, being able to like auto scale them as and when you be able to do them. So that's so from a CI/CD point of view, from a continuous deployment and delivery point of view, we have a concept within Dataflow itself So we keep track of each one of those deployment that happened on a given stream, so that there is a history of deployment for that given stream by its name. But imagine that the deployed version had more side effects, more problems, and then you get to roll back to a previous state in history from the history point of view. So data flow automatically rolling upgrade and rolling rollback to a previous stable version as well.
Yeah. So Sabby, going back to the kind of earlier definition of cloud native as loosely coupled systems that are resilient, manageable, and observable, I feel like we've covered some of those. I don't think we've talked about the observable part yet, though.
Yeah, so it's the right segue into the last part of this discussion. So here, I mean, we just got into like the building and management aspect of it and the lifecycle semantics around all these applications. But now you can see all these like buttons showing up as a Wavefront dashboard, and it all shows up here, for instance. And also in the runtime tab, you have those links to like links to like Wavefront. And so the concept is, I mean, these are all nothing but Spring Boot apps, and each of the Spring Boot apps have auto configuration. So we have auto configuration component for a variety of monitoring systems. Wavefront is one of the tools that we have in the VMware Tanzu portfolio. It goes by Tanzu Observability, and so we already have all these applications now promoting the metrics about how they are performing in real time to Wavefront dashboard. All they really need to do is I just need to like click to go to Wavefront from Dataflow UI. It's right away I get into the specifics of what is happening in my application. I have a streaming data pipeline made of 3 apps, right? So those 3 apps are the producer, processor, and a consumer. And each one of those applications are producing stats in different forms and shape. And I get to like go and drill into, from a Wavefront point of view, how they are performing from a memory point of view. What's the channel rate look like? Channel rate is interesting stat because this is where the throughput kind of concept is more relevant, right? I mean, you are processing 100,000 messages per second or 1 million messages per second and things like that. And if based on your upstream producer traffic, you can auto scale automatically also your downstream consumers to keep up with that volume that's producing and things like that. So there's all kinds of automation that's possible as well. So this Tanzu observability is something that we have as an out-of-the-box experience from Spring Cloud Dataflow, Spring Cloud Stream, and batch apps and Boot in general. And we also have other popular monitoring tools that are automatically also be part of the ecosystem. Like, for example, we see Prometheus is more commonly used in Kubernetes, for example, right? And once again, we have all those dependencies for Prometheus baked into the Spring Cloud Stream application that I have. And because they are automatically also promoting, and now the same application is promoting metrics to Wavefront, it's also promoting metrics to my Prometheus cluster that's running locally in my Kubernetes cluster also. And I have Grafana running in there, so I have port forwarded to Grafana there. Now, this is the same exact dashboard that we saw in the Wavefront. Now, I have those applications that are promoting real-time stats and metrics and whatnot. Let me go on a 5-minute window, so then it'll be like a little bit more richer. And on the same exact concept that now also on the Prometheus and Grafana stack. So you have all these options that it's available. So you get to choose what dependency that you want in your Spring Boot app and start promoting all these metrics to the monitoring system of your choice. And that goes back to that observable concept that we spoke about early on.
Thank you. This has been a great demo, a great walkthrough of cloud native data pipelines. Thank you for being here today. In closing, are there any other resources that you want our audience to know about?
Yeah, so I was in this original page when we started this discussion. So dataflow.spring.io is a microsite focused on this cloud native data pipelines, specifically Spring Cloud Dataflow. We have a variety of getting started guides for different platforms that we support. And there is a documentation, feature guides, and recipes for different architectures that we see our customers doing at scale. So all this would be useful information. And if in case if something is missing, and if you have any questions for us, we're also always listening in Stack Overflow and Gitter, so feel free to reach out to us.